Alright, so last week we started the long division of polynomial then. And you got one homework. Let's quickly get through that homework. You're asked to log divide something again. Not that one. Oh, I didn't tell you that you need two separate ones. So how you want to do character? They have to transfer well, whether you have transcribed or you leave it, so when you're studying for module 1 test, without module 2, it's messing around with what it's studying. You understand? I remember it's 20% of the grade. So you need to do it. Alright? So, what the homework? Yes. We did long division of polynomial. Yes, I give you some. I didn't give you anything homework. Okay. No. Okay, those are all you see, right? So you're going to do it unless you have issues. Alright, so since I didn't give you anything, let's do this one quickly. Suppose in the exam that they give you, let's give you an easy one first. Eh? Suppose they say find the remainder and find the remainder when f of x equal to 3x cubed plus 5x squared 2x minus 4 is divided by x minus.
What's it up to? X minus.
Good. X minus towards the divisor.
I put 3x cubed plus 5x squared plus 2x minus 4.
I will say x into
That, you get 3
x squared. Then
3 x.
tell you what, everybody do this for me in 30 seconds.
Alright.
I think it. Check if you understand on your own.
This was bad lookups because I didn't expect it to be a factor. Right? So let us see. How many persons got remainder 0? No? Huh? I don't know if it's 0. Somebody got 0. So let us see if it's 0. Or them teeth on the line. Oh, no. And explain to the line of the so they would have to play You were your last class, huh? You watch the video? Do you know what to look at this? Yeah, you should from polynomial. Divided down the right. And you see this supposed to recognize it?
That's that.
Did you do synthetic in here?
Wake up.
When you scrap that thing.
Tell me.
When you actually write it, instead of doing a long division, like so the long division was like 3 into 94 and 83 into that 3 into 3 was 3. Right? Instead of doing that long division, you actually do it in 2 lines. Alright, so I don't want to do that anyway. So I want to do long division. So if you guys actually get exposed to the scientific division, don't say I teach on the lie, I know the teacher this one. I tell you that there is another method, I don't like it. This is method. You must be careful what you wish for now. I did say you want to be careful what you wish for. Alright, so that's yours. Let's see what we get here, right? So we have x into 3x cubed goes 3x squared. 3x squared times x 3x cubed, 3x squared times minus 2 is what? Minus 6x squared. Then I need to subtract. To subtract, remember, I effectively change all the signs. So plus change to minus, minus changes to plus. And then if it is that the leftmost thing don't go away, that means you did something wrong, start over. 5x squared plus 6x squared is a positive 11x squared. Bring down the 2x and bring down the minus 4 that I've not used. Now I repeat the process all over again. Because if I divide this, I mean this by this again. So again, x into 11x squared. We all know that this needs to be in decreasing powers. So we need to have this in decreasing powers, and this must be in decreasing powers as well. And the highest power of the divisor goes into the highest power of the dividend. Right? So x into 11x squared goes positive 11x. 11x times all of that now, which is 11x squared, and 11x times minus 22x. Then I draw a line and subtract yet again. To subtract that effectively change all the sign, plus to minus, minus to plus. Of what I'm? 11 times minus 2. Then I subtract. See the leftmost thing going away again? If that don't happen, that means something wrong. This is positive 2x, and positive 22x is positive 24x minus 4. Why do I feel like you've been missing in action? So, yeah, man.
Just Saturday gone.
No, man, I miss you longer than that. X into 24x goes positive 24. 24 times x is 24x, and 24 times minus 2 is minus 48. Then I subtract yet again. Subtract. I effectively change all the sign yet again. 24x minus 24x are gone. The leftmost things again going away. Minus 4 plus 48 is positive 44. So why did you get negative 4?
Because I forgot to change
The sign. Okay, okay. So you're applying that method over here. Everybody have this. I'm not going to give you 30 seconds. You have a minute to do that one. Clearly. More involved. Eh? But keep these things close because the next topic we're going to be using these same examples in a different way. All right. Remember what this tells us? Yes? But when you're adding so you see, I was adding and subtracting. One of your minus, so I subtract effectively and keep the sign of one. Where you're at the 48 plus. Makes sense? Plus 48 minus. You can say can't go into event, but you can. If you consider this, when I said 3x, when I said x into 3x, technically that's what I did. Literally what I did. So, and then I would have gotten 3x squared. So that's how I would have gotten that. So if it is that you're not seeing it as clearly, then you will want to do that kind of thing. In addition, because you're clearly going to be working with fractions, the fancy calculator maybe you have significant. You guys spending all the time writing out this example, this question, and not doing the question at all. Anyway, that's going to be the last long division, you see. And then we're going to move on to something else, right? So try and see if you follow exactly when I'm going through that. If you're not already following, right? Guys, because I'm slow when I'm doing it, unlike you, that not using a calculator, you'll see me actively using my calculator. Fair enough? So let us see what we have. Can I go through now? The first thing to set it up, what am I dividing by? I'm divided by 6x squared minus 2x plus 4. Again, remember this, the term that is 4 is less than most. 2 plus 2. So this is 4x cubed minus 3x squared plus 2x plus 1. 6x squared into 4x cubed. And this is technically 4 upon 6, eh? So it's going to be 2/3 of x. Now the x squared going to x cubed. So letters going to letters, numbers going to numbers. That's one thing. So let me not use the calculator, right? Fair enough? And then this multiply all of this now. 2/3 x times 6x squared. 3 into 6 goes 2. 2 times 2 is 4. 4x cubed. And if you never get back 4x cubed, that means you did something wrong, eh? And then 2x, 2/3 x times minus 2 is minus 4/3 x. And 2/3 x times 2 positive 2 is positive 4. Oh, this is squared. And then 4 upon 3 x. That's all? That's correct? Then I subtract, my effect will change in all the signs. Plus change to minus, minus changes to plus, plus changes to minus. The leftmost things obviously go. I'm not going to play here with that. So that is minus 3 plus 4/3. And I get minus 5/3 of x squared, positive 2, minus 4/3, and I get positive 2/3. And then I need 2/3 x, that is that bring down to 1. Is that true? Yes? And then the chaos start out over. 6x squared into minus 5x squared. We can talk about the numbers first. So it was minus 5/3. That is being divided by 6. Minus 5 upon 18. Minus 5 upon 18. And 6x x squared into x squared goes 1. So this is just 5 upon 18. That's all. Minus 5 upon 18 times 6x squared. So times 6 minus 5/3, which we expect to get back. X squared. Minus and a minus the plus overall. And 2 times 5 upon 18, that looks like 5 upon 9. X. And 5 upon 18 times 2, that again looks like minus go, because minus times positive is a minus 5 upon 9, full stop, eh? Okay, subtract yet again. To subtract, I effectively change all the signs. Minus changes to plus, plus changes to minus, and minus changes to plus. Everybody follow me so far, right? Yeah. The leftmost thing, no matter how complicated it needs to cancel. And then positive 2/3 minus 5 9. 1 upon 9 x plus
4, 1, 9.
so that's 1 plus 5 upon 9, 14 upon 9. That's it. Why is it that I have to stop here? Because 6x squared can't go into x, right? So what do I have here? You can see that I can write it in 2 ways. Just like when I have a function here, and I divide it by, if I have 3 into 64, it would have been 300. I would have eventually gotten 2, 1, and some remainder, which is 1, right? So this would have been 64 equal to, there's 2 ways I can summarize this. 3 times 21, we divide the time proportion, but I need to add back the remainder. So, or I can write it as a mixed fraction. 64 divided by 3 is 21 plus the remainder upon the divide. So, keep that in mind as well. So, how many ways can I summarize that? Can you summarize that for me? Can you summarize that as in, can you write it as a mixed fraction? Can you write this as a mixed fraction? This upon this? And can you rewrite this? So using these two writings. So I can say 64 can be written as 3 times 21 plus 1. Because that's what this tells me. It tells me that 3 times 21 is not quite 64. There's something that I need to add to it to make it 64. So, or I can say 64 divided by 3. So write as a mixed fraction. 3 going to 64, 21 whole times, and then the remainder upon the divide. So that's what you get, the remainder upon the original denominator. And I was saying, can you write this in these 2 forms for me? We agreed in 4x cubed minus 3x squared plus 2x plus 1 all over 6x squared minus 2x plus 2. I want to just look at something, right? How we do it? We usually say when you have the denominator, the numerator being larger than the denominator, then it's a mixed fraction, right? Yes. But if the numerator is smaller than the denominator, then it's a regular fraction. It's a proper fraction. We know those terminologies, no? Yes. All right. So how we actually categorize polynomial or rational polynomials? It's called a rational polynomial because that's the next topic we're going into. So I can mention here. It's called a rational polynomial if I write it like this. Because what's a rational number? Anybody remember what's a rational number?
A number that can be expressed into
a fraction. That's a rational, no? So it's a rational polynomial or a rational expression if it is a fraction, first and foremost, and then the numerator is a polynomial and the denominator is itself a polynomial. You know? So even this x squared plus 3x plus 2 divided by x plus 1, that is a rational expression. That's what they're going to call it. You know? So any rational expression, I can have it as a proper fraction or an improper fraction. This one is called a proper fraction for this reason and this reason only. What's the degree of this polynomial in numerator? So the degree is 3 up top, and the degree of this one is? So can you see that this looks like if I was supposed to write a fraction of the degree, I would have an improper fraction? Yeah? So that's why this is called an improper rational fraction as well. No, it has implication, meaning it behaves just like any normal improper fraction would behave. It can be written as a mixed fraction, where I said, how many times does that denominator actually go into this cubic? And it goes into it that many times. So I write it back. 2/3 x minus 5 plus the remainder upon the original divisor. That's how we usually do, right? So, as in, well, some of us actually write this as 21 and 1/3, but it wasn't a multiplication. If you thought it was a multiplication before, you were lying, because 1/3 times 21 would have been 7, which is not 21 point anything. So it was an addition. And that's the missing in this mixed fraction, which is why we have to ensure that we write a plus in between the quotient and the remainder. So this will be 2/3 x minus 5/18 plus, and then the fraction part, which is the remainder upon the original divisor, and this should have been 1/9 of x plus 14/9 all over 6x squared minus 2x plus 2. Notice that when I now write as a mixed fraction, this part is obviously, just like here, the remainder part is always a proper fraction. Eh? Can you see that this would be a proper fraction in and of itself? Polynomial of degree 1, polynomial of degree 2, that's like a half. Fair enough? So that's how we write that. It look ugly, but I'm telling you that Mr. Keith, especially in Unit 2, you're going to be asked to write this, right, and use this expression. The other way I can write it is 4x cubed minus 3x squared plus 2x plus 1 is equal to, and I said, well, this times this times 6x squared minus 2x plus 2, but I need to add back my remainder. And if you were supposed to expand this, you would have gotten back. So think about it. If it is that the remainder was 0, then this time this would have been equal to that, right? So if the remainder was 0, this time this would have just been that. But because there's a remainder, you have to add it back because it wasn't quite reaching up to the beginning, the original beginning. Right. This one, yeah. The best way to look at it is through real number system, which is why I brought us back to that. If I said 3 into 64, I would have gotten 21 and the remainder 1. Isn't it true that 64 is 3 times 21 plus 1? If I were supposed to give you something like 63, this would have been 21 and the remainder would have been 0. You see, when it's a factor, technically what I'm doing is when I long divide is factorizing 21 times 3, right? Plus 0, right? So I want you to keep that in mind. Alright. Everybody follow me so far, right? Two? You mean 1 minute? 30 seconds? Anybody saw that I sent out a reminder last night, eh? Before class later. So we all need plans for that, right?
We did.
Yeah, we did, eh? I asked. Yeah. Good thing that you still have time to make plans for it. This one is just a reminder, to be honest, evaluating polynomials. Because I'm trusting that we all know how to evaluate polynomials. What do I mean by evaluating polynomials? Suppose they tell us that f of x equals 3x squared plus 5x plus 2. And they say find f of 1, find f of minus 2, find f of x plus 3. I want us to see how we evaluate those, right? That's what we're going to do.
Wait, do we should do this now?
You can in 5 seconds each.
Right. Okay.
As in, it's stuff that you have been doing over time. So I expect that you would have some idea of it. Right? As I said, these are more of a review than anything else. Okay. And if you can't compute in your head, please use a calculator. I'm sorry. Everybody can compute in their head, but can you compute in your head correctly? Right? That's the thing. So please, if you never practiced before, don't try to practice in the exam. Just use the calculator. You know? Right. So this is f of x. So anytime I say f of anything, just remember that it must be f of x. So now I'm saying that x is equal to 1. So anywhere I say x, leave a bracket. That's the recommendation. So 3x, that means 3 brackets squared plus 5 times bracket plus 2. And then I say, hey, what do I plug inside that bracket? 1. If I do that, everything is nice. Want to leave a bracket. So this is clearly 3 plus 5 plus 2, and that is clearly 10. Right? For this one, it's the same thing. It's always f of x. So anywhere I say x, I need to leave a bracket. Given that it was not x again, right? Plus 5 times x plus 2. What do I plug inside the bracket? Now x is equal to minus 2. And you see minus 2 is contained in bracket. Right? So it's 3 times positive 4 minus 10 plus 2. That would be 12.
12 minus 10 plus 2, which is 4.
Right. So 40 minus 10. That's all. And then look at this now. F of, you see when we see that x inside bracket now, we may get a little bit on the wrong side. So let's ensure that we're on the right side. This says, remember, it's always going to be f of x. So if it's not x specifically, that means if I say 2x in bracket, it's not x. I must still follow my procedure and leave a bracket. So this is 3 times some x, 3 times the bracket squared, plus 5 times the bracket plus 2. And what do I plug inside the bracket? X plus 3. So this is now 3, and I expand that. X squared plus 6x plus 9. Yes? You know that better, yes? Plus 5x plus 15 plus 2. 3x squared plus 18x plus 27 plus 5x plus 16 plus 2. Grouping like terms, 3x squared plus 18 and 5. 23x plus 27, 29, well, 7, 34, and 10, 44. Right? Isn't it? 54.
Oh, yeah.
54.
No.
44.
I never solved.
Alright, so I don't need to believe on this one. Everybody knows to know. Everybody knows. That's what I mean, right? Just before we actually reach it, which is in function, if you see x squared of 3, it doesn't mean let's leave that on 2. Because we know what the value of x squared, but it's not x squared. Just if I say that, it means f takes what? F takes f. So it just means I'm saying 2f. I just come with the function of a function, right? That is what it is. What's the function? And that's what it is. Alright. We're going to rational expressions, which is basically we will have left just a few minutes with the quotient. So, we're right back to this. So a rational expression is in this form, P of x upon Q of x. Is a fraction where P of x and Q of x are polynomials. I want to know what polynomials are, right?
So it's always going to be polynomial that we're interested in.
Of course,